The green is the dew point, the red is the temperature. As you can see, it's pretty much saturated. Except the very surface there, you can see right at the surface is a little bit of separation. And that's important when you get in some of these icing events. You want to have a little bit, just a little bit of dry air right at the surface. It helps the evaporation and cooling continue. And that keeps the temperature from rising. It's kind of offsets the latent heat release that you'll get during freezing rain events. And so you can see, if I can put it right here, this is, if you can tell, the temperature there is poking right at or just above freezing there at the surface. It does. Now let's pretend we live, pretend we live a couple hundred feet up. Look where the temperature goes as you rise, the first 50 millibars. The temperature actually cools. Probably cools down to about -3 Celsius, -4 Celsius there. So the temperature's getting into the 20s as you rise up the first 50 millibars. So this is an example right here of how a little bit higher up. I mean, obviously, if you're up on a mountain, it might be, if you're up on a mountain at 900 millibars or something, you're not going to be getting any ice out of that. But some of the hills, 1,000 feet up or even just 500 feet up, they're going to be more susceptible to ice because you actually see the temperature decreasing before it increases. And again, look at the 825 millibar temperatures, like about +6 or even higher. So when you're looking at the typical NSET maps and you see 850s of +8, doesn't necessarily mean you're not going to have a frozen precipitation event, as I'm sure many of you are aware, but it's something you got to keep in mind. I think during the December 2008 storm up in New England, much of the area had +10 850s, well above freezing. So that doesn't always tell the story, especially in these events. And here's a picture. This is up on ice on Ox Hill, Fairfax, Virginia. This was, I believe, once the sun came up in the morning, once it got light out, this was the ice. And you can see it looks like that's a classic looking glaze on all the trees of ice storm. Whereas you could have lived a mile away and 100 feet lower and you had nothing. But if you had gone over all the mesoscale aspects of that event, you might have expected some ice if you were up around 500 feet in elevation. So that's something you have to be aware of when you're looking at icing events. It's not always cut and dry synoptically. There's a lot of little weird things that go on, mesoscale, even on a micro scale, where elevation can play a large part in other factors too. You have to look at those cold air damming setups. You have to look at the ageostrophic flow, and then you can better forecast these, because a lot of these events like these are not forecasted well all the time, as I'm sure some of you are aware. You can have some pretty big busts, and it's a big difference when you're talking about ice. It might be one thing if you forecast 2/10 of an inch of rain, you get 1/2 inch of rain instead, versus when you forecast a few tenths of an inch of rain and you get a few tenths of an inch of ice. It's a much bigger impact on everyone. Okay, now I'm going to talk about a really bad ice storm that hit Massachusetts, New Hampshire especially, but even parts of eastern New York and even extreme northwest New Jersey got hammered pretty good in this event. And of course, this is the December 11th and 12th, 2008 ice storm. And there was a lot of mesoscale forecasting things that went involved in this. A lot of the traditional perception, a lot of the traditional ideas about ice were kind of thrown out the window in this event. This was a very heavy QPF event with intense precipitation rates. And despite that, it was still a ridiculously destructive ice storm. I mean, a lot of areas had 1 inch to 1.5 inches of ice accretion on the trees. And usually, as I had mentioned before, lighter QPF, or lighter rainfall rates anyway, tend to lead to better accretion. Now, that's still true, but what was weird about this one is that it came down so heavy, but yet we still accreted pretty well. And there were a lot of mesoscale aspects that went into this. And